Hey everyone, it's Cal from Wise Guys Tutoring. I'm here to solve the EmSAT Math Sample Test from 2022. We'll be doing questions 16 to 20. I'll remind you one more time that I do offer private and group lessons for the EmSAT. So hit me up on Instagram at WiseGuysUAE or send me an email at info@wiseGuysUAE.com. And as usual, I'll try to give you guys a background on each topic for each question. So not only will you have the answer, you'll have, a general understanding. Let's get started with question 16. This question says, use the parallelogram below and given conditions to answer the question that follows. What is the length of BE? So they've given us AE is 16, it's written here. BE is x squared minus 48. So I like to put that down. Whenever they give me some info, I like to put it on the drawing if it's not there, on the diagram. And DE equals 2x. So DE is 2x. Here's the property that you need to know in a parallelogram. When the diagonals intersect like this, they bisect each other. What that means is that the length of BE is going to be exactly equal to the length of DE. Okay, so these two are going to be congruent, and these two will be as well. So AE and CE will also be the same measure. Okay, so I could write that down. So AE is equal to CE. They're both going to be equal to 16. And at the same time, we know that BE is going to be the same as DE. So this is the one we're going to work on, right? Because they're looking for BE anyway. So we're going to substitute the length that they gave us. So x squared minus 48 equals to 2x. Now this is a quadratic. And to solve a quadratic, the way we do it is we like to get everybody on one side. We make it equal to 0 and we try to factorize. So I'll subtract 2x on both sides. That's basic algebra, right? So I'm going to move over here so we can have a little bit more room. So minus 2x minus 48 equals 0. And this is a shape I like for factorization. So I'm going to try to find two numbers that give me a product of negative 48, while at the same time giving me a sum of negative 2. And if you're not sure how to do this, I'll put the link up there on how to solve quadratic equations this way. So, you rack your brain and you figure out that it's minus 8 and 6. When you multiply these, they give you negative 48. And when you add them, it gives you minus 2. So all I have to do is actually put these back into the equation. So this becomes x minus 8 times x minus 6 equals 0. That means either this guy here is 0, which means that x would have to equal 8, or this term here is equal to 0, in which case, oh, I'm sorry, that's a positive 6, isn't it? There you go. In which case, that means that x is equal to negative 6, right? Now, obviously, these are lengths, right? If x is negative 6, that would mean that DE is 2 times negative 6. That would mean that DE is minus 12. It's not possible. So we have to actually reject this solution. This is the correct solution. X is equal to 8. Now, have we answered the question? No, we have not, because the question is saying what's BE. So let's go over here. We'll keep it green. We know that BE, we've been told, is x squared minus 48. Now, x is equal to 8, so all I have to do is substitute 8 in here, and I'll get my answer. So 8 squared is 64. 64 minus 48. This is equal to 16. So the correct answer will be 16. I'm not sure if these are centimeters or what. There's no unit, so we don't have to put a unit anyway. I'd like to just point out that this is not possible for all of them to be 16 unless this thing is actually a square. Okay, because if it's a parallelogram or a rhombus, which is just a parallelogram with all equal sides, the diagonals will not be the same. But in this case, they're all 16, so it's got to be a square, which it doesn't look like, but there you go. Anyway, let's move on to 17. This question says, the results for a survey of 120 students who were selected randomly are listed below. 60 students have a mobile phone from the company A, and 36 students have a mobile phone from the company B. 24 students do not have a mobile. Oh, poor students. The total population of students was 380. Based on the data, what is the best approximation for the total number of students who have a mobile phone from company B? So this is a sample, right? That's what we call it, because the total is 380 students, but we only asked questions to 120 students, right? Because sometimes asking for a whole, what we call this is the total population, this is 380, it's not a big deal, but let's say it's like a city or a country, right? You're not going to go asking a million people what kind of phone company they're using. So you use a sample, you use a small portion which is meant to represent the entire population. So right now we have the data for this sample of 120, right? 60 plus 36 plus 24 is 120. So they're all accounted for. So now they're asking me about the best approximation for the total number of students who are using mobile phone company B. So let's focus on mobile phone company B. There's 36 students, right? That means out of 120, 36 of them use mobile phone company B. If you would to make this into a decimal or a percentage, this would be 0.3 or 30%. So if I'm looking at the sample and I have to assume that this sample is a good representation of the 380 total students, that means it's going to have the same proportion. I'm going to have 30% of these 380 students. And whenever you're taking percentage of a number, what you do is you multiply it. So this is 30% in decimal form, and you just multiply it by 380. So if you punch that in your calculator, you're going to get 114, making the answer this top right one right here, 114. I'd like to say something here where best is written in bold, right? Beware, it's the best approximation. Why is that the case? Well, just because these 120 students, 36 of them had mobile phone company B, okay? It doesn't necessarily mean that exactly 114 out of 380 also had mobile phone company B, okay? It could happen that the 120 students that I picked, maybe these guys are more prone, you know, just so happens like they live in a neighborhood or you know, they're signed up to some school or some club where they get a discount for company A, so most of them, half of them have company A. But it doesn't mean that the rest of the people will follow these proportions, okay? Again, this depends on the sample you're taking. If you take a good sample, like a good enough size, and it's properly selected, like randomly selected properly, then you will have a good approximation. But again, it's always going to be an approximation. Okay, it's not 100% sure that exactly 114, but that's a good guess. All right, let's do question 18. It says the population of a small city in 2010 was 36,000. In 2015, the population was 43,800. So it's growing. If the population growth is linear and growth occurs at the same rate, what will the population be in 2020? Round your answer to the nearest whole number. So this is a linear equation. So what we can do is make a small table of values. As long as they gave us two data points, okay, we're going to be able to find the equation of this line. And once we find the equation of this line, we can predict absolutely any population for any year that you want, okay? Assuming again that its growth is linear and its growth occurs at the same rate, which they told me it does. So let's assume X for now. X is the year, okay? Here's the year. And let's assume that Y is the population, okay? And they've given me a couple of data points to work with, right? When it was 2010, the population was 36,000. And when the year was 2015, the population grew. It's now 43,800. And in 2020, we don't know what it's going to be. That's what they're asking, right? So here's what we're going to do. We're going to try to find the equation of this line, okay? There is an easier way to do it, but I'll take the opportunity to show you how to find the equation of this line, okay? Let's use the form which is called the slope-intercept form, which is mx plus b. And I'll put a link up here which explains really how to use this form and what each one of these means. And I really highly recommend you check it out because linear expressions are a big part of algebra. Okay, so first thing we're going to focus on is how to find m. M is the slope, or some people call it the gradient. And the gradient is found by doing rise over run. That means the difference of increase in y, which is the population, divided by the increase or decrease of the run, which is the year in this case. Okay, so all you need to do is take these 2 points and plug them in. I'll assume this is like point number 2, and let's assume this is point number 1. So I'll start with y2, which is 43,800, and I'm going to subtract y1, which is 36,000. I'm going to divide that by x2 minus x1. So x2 is 2015, and x1 is 2010. you put this in your calculator, you're going to get 7,800 divided by 5. And if you put that again in your calculator, you're going to get 1,560. Okay? What this means is that every year it's going to grow by 1,560. So the next thing we need to do is find B. And B is the initial value. So how do we find B? So this is, we call it the y-intercept. It happens when x is equal to 0. So this is always the initial value, right? It's like the population when the time was 0, quote unquote. And the way that we can find that is by replacing our y and x. So I now know that my m here is 1,560. That's my slope, right? That's my gradient over here. How do I find b? Well, I know that this combo, let's say point number 1, this combination of x being 2010 and this combination with y equal 36,000, when I put these in here, this equation must be valid. It's got to be true, right? So this is 2010. So B will have to oblige. B will have to make himself some kind of value which will make this equation true. So again, if you multiply these using your calculator, probably you will get 3,135,600 plus B. And if you want to get B all alone, then you subtract this number on both sides. So minus 3,135,600 on that side, minus 3,135,600 on that side. These cancel out, and you'll get your B. So the value for B is negative 3,099,600. There you go. So now I've actually found, I'll go all the way over here and I'll put it in green. Y equals 1,560 times whatever year it is, minus 3,999,600. Okay, so now any year that you ask me, I can just substitute that value for x and I will find a new value for y. So if you tell me the year, which is x, I can tell you the population, which is y. So in this case, they were asking me for the population when the year is 2020. So all I have to do is substitute 2020 instead of x. So if I say y equals 1,560 times the year 2020 minus the initial value we found, then I will get a population of 51,600. So that'll be the answer. Doesn't really fit in that box the way I write. So there you go. 51,600 will be the population. And that's already to the nearest whole number. So we're fine. We're good. Okay. An easier, a simpler way, once you have a solid understanding of what's going on, this slope means, like I told you, this is the increase. This is the growth of how many, let's say, people per year. That's how many people per year it's increasing by, right? Now, I know by looking at this table of values, now that I've set it up nicely like this, I know that when 5 years have passed, right? This is 5 years. Well, how much was the increase here? The increase here was 7,800 people more, right? So if I'm looking here, guess what? The numbers that they gave me, that's another 5 years. And since it's linear and the growth is consistent, right? It's linear. That means it's steadily increasing at the same rate every year. Well, then this is just going to be another 7,800 added, right? And if I add 7,800 to this value, you get, you guessed it, 51,600. Okay, so it all works out is what I'm saying, right? That's what I like about math. There's several ways to find the same thing, many paths, one spot to land on. So 51,600, I'm very confident with that answer, and you should be too. All right. Hopefully you've learned about the linear equations. Again, check out that link that I put up before. It's really, really important that you master this. Okay, let's move on. Number 19 says, on the grid below, rectangle ABCD is rotated 90 degrees clockwise about the origin to form a rectangle W, X, Y, and Z. Which statement about the relationship between rectangle ABCD and WXYZ is true? So first of all, let me do it the obvious way. Okay, let's say BC and YZ. This symbol here, by the way, means congruent, right? So congruent is the same thing as equal, but when you say you're talking about shapes or you're talking about geometric elements like lines and stuff, you can't say one triangle is equal to another triangle, right? It doesn't make sense. You say one triangle is congruent to another triangle. You use equal for numbers, for measures, things like that. So here they're saying BC is the same as YZ. So if you look at BC, which is 1, 2, 3, 4, 5 units long, is it the same as YZ, which is 3 units long? No, it is not. Because when we are doing a rotation, the size does not change. Okay, that's important. In rotation, the size remains the same. All the length will remain the same. Okay, you can't grow and you can't shrink by rotation. You just change the orientation. So if this one has changed, this one is definitely out. You look at DA and YZ. So DA is here. It's another long one. And YZ is again a short one. So definitely not this one. Okay. You look at DC, which is a short one, compared to XY, which is a long one. So definitely not this one. And then you look at AB and WX. So AB is over here and WX is over here. That's the one. So this was not a great question. You can tell immediately by the different sizes. As long as you know that rotation, the size remains the same, then you can totally eliminate these three immediately. But again, I like to give you guys a solid understanding of everything. So let's first identify which side became which side. When they say it's rotated 90 degrees clockwise about the origin, whenever you're doing a rotation, you need three things. Okay. First thing you need is the center of rotation. So where is the center of rotation? They've told me it's the origin. Origin means 0, 0, right here. You also need to know the direction. Now the direction can be one of two things. It can be clockwise, which is like a clock, if you guys know a clock. And if you don't know, then I swear to God, I recommend you just wear a watch to your exam. And there's counterclockwise, which some people call anti-clockwise, which is the same thing. And that actually goes the other direction, which is like this. Okay. Third thing you need is the degrees of rotation. Normally what you'll see is like 90 degrees, 180 degrees, and 270 degrees. But rarely will you see 270 degrees because they're kind of the same, right? If you look at a circle, if this is the center, then 270 degrees that way is the exact same thing as 90 degrees that way. Right? So usually they just use 90 and 180. So in this case, what we're going to do is this. Let's start with point number C because he's the closest. So point number C, what I do is this. I'll connect like a little L shape over here. If I was to rotate this L shape by 90 degrees clockwise, what happens is it's going to rotate that way. And when you rotate something by 90 degrees, every horizontal line becomes vertical and every vertical line is going to become horizontal. So hopefully you can picture that this is hinged over here. It cannot move from this point. So this horizontal line becomes vertical and he measures 1, 2 units. So he's going to end up like this. And this vertical line, which is 1 unit long, becomes horizontal. So now I know that the point C is the point Y. Okay, so maybe we'll put that in the corner that C is Y. We can do the same thing for all of these. So let's do D. Let's say I'll make it red, right? So from the center of rotation to here, that's 1, 2, 3, 4, 5 units. And there's 1 unit up. Now this horizontal line becomes vertical by 5 units. So 1, 2, 3, 4, 5. And this vertical 1 unit line will be 1 unit to the right. So D is Z. So now I'm able to tell that this side CD is the same one as YZ. See? We can do the same thing for A, so let's find A. Maybe I'll use green or something. So if I go to the left, it's 5 units, and if I go up, that's 1, 2, 3, 4, 5, 6 units up. So again, this 5 unit one becomes vertical when I turn it. vertical, and then 6, which was vertical, becomes horizontal. So A is W. And again, I can mark that side. I'll do orange. So now I know that DA or AD or whatever is this side here. Now that I have this corner, it becomes pretty obvious for the rest of them. So we can use, for example, yellow line for AB. AB is this one. Yes. And how about a pink line? This side here is that side. So when you do it like that, you can tell which one is true. And the only one that's true is that AB is WX, right? This yellow line is that yellow line. And this is the reason why. But like I told you, I'd like to give you the shortcut too. If you're able to spot it, that's good too. All right, let's move on to question 20. Let's do this last one. It says, let f of x be the function whose graph is shown below. There it is. Which of the following statements best describes why f of x is discontinuous at x equals c? So it's discontinuous first of all, because if you can see here, there is a hole. When you see this white dot, that means there's a hole. There's a discontinuity. Okay, there are several other types of discontinuities, so we can talk about jumps. For example, if you have a graph which goes like this and then it jumps to a different kind of graph, this is a discontinuity. You can also have graphs which have vertical tangents, so things like this, these are discontinuous also because they are disconnected, they're disjointed. It can also be a vertical tangent where they both go in the same direction. It doesn't matter, but this is still discontinuous. This one here is a hole. It's a hole discontinuity. So for a function to be continuous, this is the general definition that you need to know, is that the limit as x is going to, in this case I'll use c, as x is going to c of f of x, it has to equal f of c. Okay, that means the limit when x is c. And remember, we talked about limits. I'll put the link up there for the previous question that we worked on. So you have, as you're approaching this value from the left and you're approaching this value from the right, you get to the same value of 2, right? However, we can see here there's a black dot. That means this function is defined at c, but it's different than what it is as a limit at c. Let me say that again. The limit as x is approaching c of this function f of x is equal to 2, right? We can tell the closer we get to c, the closer we get to the y value of 2 from either side. So that's a limit. But if I'm looking here at c itself, the function is defined as 1. So f of c is equal to 1. Okay, we look at this solid dot because here it's undefined, but here it is defined. And here you can see that we've broken the rule, right? We've broken the rule to be continuous, because the limit as x is going to c of f of x is not equal to f of c. They are not equal. This function is discontinuous at c. So that's the condition that we were looking for. The rest of them, it says fc does not exist. F of c does exist. It's 1, right? Just because there's a hole here doesn't mean this one doesn't count. This one still counts. So this answer would be incorrect because f of c is 1, as we've just seen, right? This one is saying the derivative at c is not equal to the derivative at c plus delta x. Basically, there is no derivative at c anyway. If there's a discontinuity at c, there's not going to be, it's not differentiable at c. You can't take the derivative. And here it says limit of f of x does not exist when x is approaching c. It does not exist. That's not true. It's always going to be the same from left and right. It's approaching 2, so this is also not true. All right, so that's it for this video. Hope you enjoyed it. If you have any questions, comments, suggestions, please leave them to me below. Please like the video and make sure you subscribe to the channel. I've been dropping a lot of videos lately, so make sure you don't miss those. If you need any private or group lessons, just hit me up on Instagram at WiseGuysUAE. And yeah, I'll see you guys in the next video soon. Thanks for watching.